Alright, now let's talk about some of the additions you can do for Lab 10. And the code that I have on this page, I'm going to save this as a document so you can get it in the SI resources. But the first few lines here, that's the code that you need to use the buttons on the board as the clock, and it uses the bottom of those 5 or 4 buttons depending on how many you have on your board. And this is the constraint that you've used before. If you can lay your hands on that extra button module, that really does help keep you from having errors, because a lot of times it'll register that you pressed the button twice when you really just pressed it once. And if you use that one as your clock, then the difference would be that's pin J1. And then you always need to have this variable right here, the CLK, that needs to match whatever you called the clock variable in your code. And so this first constraint is if you're going to use the button on the board for your clock. The second one is if you're going to use the button module. Now, another thing I demoed was using some of the LEDs to represent the sequence that you've entered, and there are lots of different ways that you can do this. But if you do it, then you'll need to make sure that you have as an output LED, and your state is 4 bits, so this would be output reg LED reg 3:0 LED, and I think the easiest place to set it up is right here. So when you are saying what the next state is, you've just determined what the new state is, and then you can put your current input into LED 0, so make that equal to your current input V. Well, there was something in LED 0 before, so why don't you just do a little shift? So why don't you just shift it down so LED 1 becomes what LED 0 was. Now, if you do it in this order, the way I'm doing it, you have to use the non-blocking, because if you didn't use non-blocking, then if you just did LED 0 equals V, then on the next line, LED 1 would become equal to V because you just changed LED 0. But if you use the non-blocking assignment, then it won't change it until it'll use the values that they had when you got into the always block. So LED 2 will become equal to LED 1, and LED 3 will become equal to LED 2. So that's part of what you need to do. Now you'll need to also make sure that, now I called them LED because I like to be lazy, and that's what they're already called in the constraints. But if you go and you look at the constraints, if you look at the template file for the LED, so they're just called LED. And so I used the first 4, so 0, 1, 2, 3, 4. 0, 1, 2, 3. You can use whichever ones you want. Yep. Now, if you set the LEDs, you're going to want to make sure that you turn them off if you are repeating, you're doing another, looking for another sequence. And so I thought the best way to see when it might be a good time to reset them would be if I was in state A. Because if I'm in state A, that means I'm in the state that you go where you reset. And in that case, and I'm doing this the start here, let's see, begin, then I can make LED equal to 0. I guess that's all I need to do, so I don't need to begin. Yeah, but I will also want to do the same thing if I reset. Let's see. I also, when I did this, so you need to define LED, I initialized it to 0 right here. I think that's it. So, to use the LEDs, just make sure you uncomment them in the constraints. Now you could also use a 7-segment display, one of the 7-segment displays, to indicate what the current input is. And if you did that, this is not something that I have tried, but let's see, you would need to make sure that you had in your constraints so if you use the 7-segment display in your constraints, you would want to make sure that you uncommented out all of your segments. So segments 0 through 6, and then I sometimes also use this one, the name of it in the template is DP for decimal point. I sometimes use that one as well, but you don't have to worry about that. And then you would also need to uncomment out these ANs, because that tells you which display you're going to use. So let's say you just wanted to use one display to say what the current input was. How would you go about doing that? You would have an output, and this could be instead of the LED. I'm just going to add it here with the LED. Seg AN output reg, and we want to do this 0:6 seg output reg 3:0 AN. I'd like to just point out that what I'm doing right now, all the things I'm doing right now, are optional. I'm just showing you different things you could do. You don't have to do all of them. You just want to make sure that you have a good project. Alright, so now let's say that what I wanted to do was to display on the 7-segment display what the current input was. So I could do that here. so if the current input is 1, then I can say if V, because V is my current input, AN equals 4B, and I'll pick one of the displays, 1, 1, 1, 0, so that's the 0 display, and seg equals 7B, and then I would need the correct sequence for a 1. So a 1, I think, would be 1, 0, 0, 1, 1, 1, 1. I think that would be it. If you think about the 7-segment display, that's 0, 1, 2, 3, 4, 5, 6. And so to get a 1, if I used 1 and 2, I'd put a 0 there, and I'd put 1s everywhere else. And that would make those light up. And so then while I'm here, if I wanted to do a 0, I would want all of them lit up except for 6. So these is 1, 2, 3, 4, 5, 6, 1. So that would be a 0. So, actually, I can have this, I could use the same display. For both the 0 and the 1. Oops, so I put that before the if. Okay, and then I don't need the begin anymore. So if V, then I make the segment equal to 1, else I'll want it to be equal to 0. And so this would have a display, and that would show you what the current input was. Okay, I'm just going to try that out because I have not actually done it. So let me uncomment my 7-segment display. Uncomment those. Uncomment AN. Save. Go to my main. That only needed to be a 3. And then put these in. Let's see, what are my errors? B is not declared. Did I call it F? I did call it F. This was real interesting. So I loaded this onto the board, and it kind of worked, except it was showing the display on two separate of the displays. And I'm like, oh, it's not supposed to do that, and I don't know why it was. And then I see here I have this as a 3-bit variable instead of a 4-bit. So it's saying that AN is 111, just 111. And so I'm guessing that's where the problem is. But I am not going to wait for it to compile.